Hello everyone, welcome back to my channel, Fun Coder. I hope you've been enjoying. I've been taking a lot of time to create good content for you guys. Let's dive into new topics that I created for this week. We will be looking at sampling, quantization, and storage in digital image processing. So here are the contents. We will look at two different algorithms that I've come up with for sampling and how time efficient they are. And we will also look at quantization, the basic strategy of creating the algorithm, and then what are the uses or advantages of these two in storage. So here is one algorithm where I am taking a matrix and defining two steps either in row or column. Based on the user provided number of steps, I could pick the pixels at that location. And of course you need to use some loops to jump from one place to another in row versus the column, and place each pixel into a new matrix which is defined ahead. So here, as you can see, we have two different loops and to go row and column for these step units. So we will also look into how the time, how much time would it take for this algorithm later after defining algorithm 2. So MATLAB has a special feature where you can use this sample code, where you see just by picking the row how much unit you want to move within the matrix. So if you use that, we will also look at what or how much time it will take for executing this algorithm, and it would be without any follow-ups, only one step code. So this is the time efficiency between both algorithms. As you can see, this is the original image, is the shrink image, and we can see it's quite significant difference. About 3 milliseconds we can reduce. You might be wondering why this time efficiency is important. Of course, if you want to transmit the data over the channels, right? You want your code to be taking less time. And we will look at quantization in the next slide. So as a before I forgot to tell you guys something here. To execute or get the time information, we can use some TikTok functions that MATLAB provides us. I will put it in the description box in after the video. You can review those. So in quantization, the basic idea of quantization, you might have seen single signal 1D signal quantization, where you divide the amplitude of the signal based on the number of levels defined. So it's essentially the same. Since this is a 2D image, we would define the number of levels based on intensity at each pixel. So the basic mathematical representation of amplitude or intensity is L is equal to 2 power k, where k is your number of bits in a pixel. So why we would need this? Because human eye is very sensitive to luminance and chroma. So by reducing this kind of high frequency, we can use for various different applications. That's what major automotive industries have been using as well in many of the cameras, which is YCBCR. So this is the algorithm how I've defined to execute. See, here we have the flowchart which describes what is the levels I've defined, and then the gray image that you want to quantize. Then for MATLAB, I've learned from my colleagues that we have to use a zeros matrix that is much stable than defining pointers and things like that. So I have defined a zeros matrix of the same size, because when I'm doing a quantization, I don't want to change the size of image. Keeping the same size of image, I just want to cut down the levels at intensity of each pixel. So what I'm doing is I'm getting the maximum intensity of each pixel of the overall image, and using that as my basis to define the levels based on number of levels provided. So I cut down into blocks and look at based on how many levels user requested. I apply this mathematical representation in my algorithm where the pixel value is less than max intensity over level plus 1 and multiply over L. And this level is already constant levels defined by user, maybe 4, it could be 8, it could be 16, but this L keeps changing and from one level to maximum level, lower to maximum level. So I keep processing that and then go inside the loop and get each after I define the zeros matrix, I get each intensity value, check for this, and keep adding 1 in the image. At the end of the processing, I will be getting based on the number of levels, each block will be assigned unit 1, and that keeps incrementing until if a user defines 4 blocks are covered. So here is the output image, original image that I've taken to quantize into level 4. You can see my maximum is 3 and minimum is 0. And here I'm defining 4 levels from 0 to 3. Use of this kind of sampling or quantization, they are basis of highly complicated or complex algorithm in image processing and computer vision. They are basis for compression algorithms and many various use cases with these basic algorithms. So I've also included some storage use cases with the computer memory and all those. In image processing of the cameras, you can think of there are various number of storage properties. So you can have short-term storage, you can have online storage where you can fast recall like your tape or magnetic discs, optical medias, and then you have an archive storage. So in an image, if you consider an image, each image each pixel is assigned with 8 bits, and it can occupy a total of 1 MB. So these frame buffers in short-term storage are a temporary storage space allocated. It could be within the serializer, deserializer, the transmission between them, within a camera. So instead of sending the whole image, you send the line by line or information in buffers to transmit over the other side, and then it retrieves and gives you the whole overall image. This is one particular application why storage plays an important role in automotive industries. Um, so thank you for watching my channel. Please like, share, comment, and subscribe. uh, I hope you guys enjoyed watching my channel, and if there is anything, any suggestions, please put in the comments box below so I can look into those and do my best in upcoming videos. Please subscribe to my channel so you can get notification as soon as I put some new video into my channel. Thank you guys, have a good one.